So here is part 1 of practice exam 4 question. I'm just going to do this one and then dive into part 2. The reason I'm going to do this one specifically is because I'm kind of doing a bait and switch on you. Sorry. When we covered these in homework, I said just use your calculator and hit the buttons. And then all of a sudden, here it is on part 1, no calculator at all, let alone a fancy graphic calculator. Yeah, sorry, I was running out of time. This is the story of my life. I was running out of time back when we were in the homework in this section. And I didn't want to do these by hand. So I just said, hit the buttons on the calculator. And so when I did see this before today. I saw this last week, or earlier this week, can't remember which, a few days ago. And I looked at it and went, oh, shoot, I put that on part 1? And I told them just to use their graphic calculator when we did the homework. And now I put this on part 1 with no calculator at all. Shoot, should I move it? I thought about moving it around and redoing the task. And then I thought, no, they do need to do that by hand. Sorry, maybe that's not the conclusion you're hoping. But it is important. It is valuable. If you're going to, my job is to get you ready for future Calculus 1 as the next class. You do need to know how to do 3x3s and things like them by hand. It is something you have to do not all the time, but you have to do every now and then as you move up the line. And you might think, well, can't I just always use the calculator? They'll give you ones that aren't linear. The calculator can only do the linear x. They'll give you like x squared and height. Anyway, so you have to know how to do it. Now, it's not that bad. It's actually not that bad. Let me give you a game plan. So what I'm going to do is I'm going to label these equations 1, 2, and 3. You just got to stay a little bit organized. It won't be that bad. We call that thing a 3x3. And as you move up the line in higher math, that's called a 3x3. Why? It's 3 equations, and there's 3 letters. So it's a 3x3. 3 equations, 3 letters. And basically, you've got to take the 3x3 and boil it down to be a 2x2. That's how you do it by hand. You've got to make the 3x3 into a 2x2. How do we do that? You've got to eliminate one of the letters from all the equations. You've got to get x to drop out of everybody, or y, or z. It doesn't matter. Pick one and eliminate it by adding the opposite and getting it to drop out. So, for example, I could do x. I'm not going to do x. They want x in the end, so it wouldn't really be a smart plan to eliminate x. But I could, in general, that would be something that would work. I could take the top equation, for example. I go, look, I got to make that x cancel that. 2x. So, or y, first off, I'm getting lost here. First off, I could just, don't write this down. I'm not doing what I'm actually yet. I could say, I'm going to get this x to cancel that one. I'll just run a negative sign through here. Negative, 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 and that'll become positive. And then I'll add these two up, and these x's will cancel. And then I could add him to the bottom one if I multiplied again by negative 2. Right? That's the same kind of thing. Now, I'd rather not do x. There's something easier. Look at y. Look at how y is really easy and ready to go. See how y has that negative y right there? If I add that to the top equation, the y's will drop out. And if I add the middle to the bottom equation, the y will also drop out of the bottom equation. And so I'll be done with y totally. And y will be out of the picture, and I'll just, a lot of flash in there, just have x and z is all I will have. So I'll have only 2 letters. That makes sense? So eliminate, wait, I can't spell that. Eliminate 1 letter from 2 equations. I'm going to do y this time. So I'm going to take equation 1, which is x plus y plus z is negative 8, and equation 2, which is x minus y plus 4z is 5. And I'm going to add those, and let's see how the y's just cancel out. Remember the addition method where you add equations? So 1x and 1x makes 2x. 1z and 4z is 5z. And negative 8 and 5, what's that, negative 3? So I'm going to call that equation number 4, just to kind of keep organized. See how I made a new equation without y? I eliminated y. I just need one more. I just need 2 equations that both have x and z, and I can handle it from there. That would be a 2x2, and that I can handle. Now, so that was equation 1 and 2. That was equation 1 and 2. Now I'm going to go back. My favorite one, the one I want to use again, is equation 2, because he has the negative y. He has the negative y. So I really like him. He's like my tool, my hammer. I'm going to use him again and add to that one. Does that make sense? I'm going to add those two. And now y will drop out of the third one. So I'm going to reuse equation 2 again. You can do that. But this time combine it with equation 3. So I'll do 2 and 3. So 2 is x minus y plus 4z is 5. And 2x plus y plus z is minus 12. Add them up. 1x and 2x is 3x. The y's cancel. 4z and 1z is 5z, and this is minus 7. That's equation number 5. Whoops, it's off the screen. Oh, sorry about that. Can you see it over there? Yeah, there it is over there. So I've got equations 4 and 5. 2 equations, 2 letters. I've boiled. Forget about the original 3 now. Don't need them anymore. Now I'm just going to take these 2 brand new equations, this one and this one. In fact, let me just bring the other one over here. 3x plus 5z. Might just bring it right over there. So, and let me erase that line I put in between them there. So, 3x plus 5z equals negative 7. And now, so see how I've done that? I got y out of both. I used the negative y in the middle, which was super convenient. You don't always use y. You just go whatever is easiest. You could drop z out of them all, or x out of them all, or y out of them all. I did y. Now I'm down to 2 letters. Now, how can I get another letter to drop out? Multiply by negative 1. Yeah, make that a negative 5z, or the top one, whichever. I'll just do the top one maybe. Make that negative, negative, and then that'll become positive, won't it? I just multiplied the top equation by negative 1. And then add these up. 3x minus 2x. X. These cancel. Negative 7 plus 3. Negative 4. I got x. And it's none of the above after all that. There it is. Jeffrey.
How come you can use the equation twice?
I guess I would say, why couldn't you? Yeah, I'm just...
Because once you combine 1 and 2, wouldn't that become 4 and then you're stuck with that? It's not kind of odd that you're able to use it again.
Yeah, no, I hear you. Basically, yeah, these are just 3 separate... What they are behind the scenes is they're 3 lines. You know? And, well, it's a little more common. No, they're not. I'm sorry. They're 3 planes in 3 space. Whatever. You can reuse it. I don't have a lot deeper to say. Yeah, there's really no reason you can't. It's just an independent line. It's a relationship. How about that? It's a relationship between x's and y's and z's. And it's true. Whatever the real answer is, yeah, maybe if I talk that way, it'd be more helpful to you. Really, what we're looking for is what is the real... This is a relationship between how x, y, and z relate to each other. They're saying the x value plus the y value plus the z value add up to be negative 8. This is another relationship between x, y, and z. This is another relationship between x, y, and z. And what we're saying, well, we want to know what x, y, and z, what maybe like 2... well, it turns out it's negative 4, actually. Negative 4, 3, 7, whatever it is, I don't know. Whatever numbers make all 3 relationships true at the same time. That's what I'm trying to find, right? So if I add 2 equations, and I'm looking for the numbers that make the top relationship true, they also make that true, then they're going to make the result true. And I can reuse it as much as I want, because it makes any of them true. They're all pieces of truth that can be reused. Is that good? Does that make sense how we did that? So I feel like that's not too bad, right? 3 by 3. So basically the name of the game is to get 1 letter to drop out. Everybody see that again. There's a million ways to do that. But you got to do it by using it twice. You do like 1 and 2 and 2 and 3, or however you want. Just use 2 equations to get y to drop out, and the 2 other equations to get y to drop out again. Get 2 new equations that only have 2 letters. So I got the 2. This is a 2 by 2 here. 2 equations, 2 letters. And then you do the final dropout on that. So that is something you have to do as you go into higher math. Hardest thing I took in junior college, I was 3 years at junior college, was Physics 4B. Anybody headed that way? That's the electromagnetism physics. That was really hard. That was calculus is the prereq. You got to take calc first, and then you take 4A, 4B, 4C. That's the harder physics that requires, the 2A, 2B physics doesn't require calculus first. 4A, 4B, 4C. 4A is mechanics. That was pretty hard, but 4B was really hard. That's the electromagnetism one. It's all these magnetic fields and electricity passing through. Anyway, that's where I still remember, that's where I first really felt super stressed out in junior. Up through then, I was good at math. Obviously, I'm a math teacher. I did Calc 1, Calc 2, Calc 3 pretty well, not too much terrible trouble. I didn't have trouble with time on tests or anything. Study hard, test went well. But Physics 4B, I remember being in the middle of one of those exams and just thinking, just panicking, like, I don't know how to do these problems. It's crazy. I'm reading crazy big. Physics is like math with all word problems. I have great respect for physicists. They are smart people. And I'd read this huge old word problem about some electromagnetism field with a capacitor charging and a flux happening. I'd be like, what's going on here? And time was running out. And I had like 3 problems left. I remember Mr. Jones. I was up at Sierra Junior College in Rockland. Mr. Jones going 2 minutes or some kind of thing, and I had like 3 or half the test not done. Just that panic feeling, anyway, long story short, he's like, that's it, last call. I'm walking out, it's the first time I'd ever not finished a test. I was just panicked. I'm like, I can't not finish. This is crazy. I never had a time problem before that point. And I was just scribbling. He walked out of the room. I had not given him my test. I'm like, oh, shoot. So I run down the hall, and I hand Mr. Jones he's down in his office. I hand him my test. He gives me this look like, what are you doing handing me your test? Who knows what you did in the hall, copying or whatever, And he takes the test from me. He's like, I'll give this some thought. And I'm like, okay. I come back to the next class meeting. He's like, Brett, what I'm going to do is I'm going to give you a retake on a different version of that exam, which I'm like, thank you. He could have said 0, buddy. I said last minute, you didn't hand it to me. So anyway, the retake, he made it hard. He made the retake. Because then I had a little more time, and I had a second shot, so he made it hard. What he did is he put I think it was a 5 by 5. 3 by 3s are kind of hard. One of the physics problems became a math matrix, which was either a 4 by 4, or maybe I'm exaggerating the story in the years gone by, but it was either a 4 by 4 or a 5 by 5. I remember it was whopping big. I'm like, wow. I thought I deserved it, But I remember trying to, and I couldn't finish it. I remember not spending like a long time with all this trying to move the 4 by 4 and the 5 by 5 around, and I couldn't get it all solved. But anyway, these do exist as you go up the line in math and science. By the way, somebody in the last period noticed a super great trick. I don't know if any of you noticed it. I'd never seen it. Let me show you on this one. There's one really cool trick. You can be done in like one step. Look right here. He noticed that YZ and YZ are the same in the first and third equation. And all we want is X. This doesn't usually work. But this, therefore, let me show you what he noticed. If you take that one and you go, okay, 2X plus Y plus Z is negative 12. Remember, we want Y and Z to drop out because we want to get X, right? Do you see it now? Do you see what you can do? How can I get Y and Z to both drop out in one fell swoop? Yeah, multiply through this top equation by negative, make that positive, multiply through by negative 1. Then add them up. Bye-bye. 2x minus x, minus 1x really, is x equals negative 12 plus 8. Done. Isn't that cool? Nice little trick he knows. Yeah, so that doesn't usually happen. But anyway, there's all different ways. My point is there's not one way to do these. You get Y to drop out, get Z. Just get somebody to drop out. That's the game plan. Get at least one letter to drop out, and then it's smaller, and then you go from there. Make sense? I won't give you a 4 by 4 or 5 by 5, I promise. Your physics teacher probably will. But maybe we can get through part 2. Here we go. Number 9, theater, 20 rows. And we did one like this, remember? Oh, all those formulas, I'm going to give you those right at the top of the real exam. Yeah, let's talk about those formulas for a minute. So you don't have to put them on your 3 by 5 card. They'll be right at the top of the exam. That way you have room to put your unit circle, which for sure is going to be on your 3 by 5 card, right? Unit circle. So anyway, I'll give you these. This is the A sub n and the S sub n for the arithmetic sequences. And over here is the A sub n, S sub n, S sub infinity for the geometric sequences. You might not even need those middle two. I don't know why I put those there. Anyway, we'll see. But Good on that? A sub n and S sub n. Those will be right at the top of the exam for Tuesday. Okay, so let's go through. So theater has 20 rows, 28 seats in the first, 33, 38. What do we do? How do we do this thing? You understand the idea, right? We have this theater that has it's got like 28 seats. And then it gets a little bigger. The next row has whatever, 33 seats. The next row has 38. Whoop, that's a 38 there. 38 seats and dot, dot, dot. And altogether, there are 20 rows. Get the idea? It's pyramid seating, basically. Just gets wider and wider and wider and wider. 20 rows altogether. First one's 28. So really what they're asking us to do is take 28 and add 33 and add 38 and etc. For 20 rows to add up all the seats. So which formula is that? We're adding them, We're not just, it's not just comma, comma. We're not just listing them. We're adding them up. So if we're adding them up, which formula should we use? S sub n. S sub n is for sum. It's this one. How do you know it's that one and not this other one over here? It's arithmetic. What does arithmetic mean? Arithmetic's adding, subtracting, right? So you jump from number to number by adding 5. It's not multiply. You don't go times 5 every time or times anything. You add 5. That makes it an arithmetic sequence. So the first two will be your easier ones, your arithmetic. The last three will be your harder ones, your multiply ones, your geometric on that. Rudy? The A sub n? Yeah, the S stands for sum. These plus signs are sum. Yeah, so when you're adding, so A sub n, if it was like 28, if they said, hey, here's a list of numbers, find the 70th number. Like if they gave me this and said, hey, find the 70th number, then I'm not adding anything up. Then I would just use A sub n. But if you're adding things up, you're doing a sum, S sub n. Good question. All right, S sub n. S sub n it is. So let's write that down then. Let me kind of get this out of the way here. And we'll do our S sub n formula. So S sub n is n over 2 times A1 plus AN. All right, A1, what is n first off? What does n stand for? Remember, it's the number of terms, and A1 is the first term, and AN is the last. You might want to write that in your three. Even though I'm giving you the formulas, I'm not explaining what every piece of them means. So you might want to do that for yourself on the 3x5 card. Number of terms is in. A1 and AN are first and last terms in the list. Okay. So then, the S sub n is number of terms. Do we know the number of terms? Yeah, 20 rows, 20 rows. So there's 20 rows. A1, what's A1? First term, that's A1. Now, what's A sub n? What's the last term? I don't know it, We don't have that. So what should we do? Yeah, use the A sub n formula, shouldn't we? What's the A sub n formula? Right here. So this is going to be A1 plus n minus 1d. Is that making sense? So right there, I'm putting a in. Or maybe easier. Would it be easier for you if I just put it off to the side? Whichever you want to do. Doesn't matter. So I'll just say, okay, A sub n over here on the side. A sub n, I'm probably way off the screen, or about to be. So I'm running out of room here. So I'll do it over here. A sub n is A1 plus n minus 1d. So that's A1. A1 again is 28. Plus n. N is the number of terms. That's 20. Minus 1. What's the d? It's the 5. It's the difference from term to term, the jump. So that's 28 plus 19 times 5. That's 28 plus, what's that, 95? And that's 123. AN's 123. And now we can finish working this thing out. 10 times 151, 1510. 1510, answer C. 1510 seats. So questions I can answer. See how I knew they're being added up, so it's the S sub n formula. Plugged in, it's n is number of terms, first term, last term, A1, AN. I didn't know the last term, then I had to use the A sub. That was a lot of work. That problem's long. Questions? Good. All right, let's move it. So, how do we find the 42nd term of that sequence? Am I going to use an A sub n or an S sub n? Yeah, because they're not being added. It's not a sum. So it's just A sub n. Now, which one, though, is it? Because we have two A sub n formulas. Is it the easier one or the harder one? Arithmetic geometry. Yeah, you just ask yourself, what's happening from term to term here? Minus 4, minus 4. It just keeps doing minus 4, huh? It's just adding, subtracting. It's arithmetic. So I use the easier one. Whoops. Which is A1 plus n minus 1d. Is that good? If you go back to the list here, it's this first one right here. It's the arithmetic. Okay? So then A1, that's the first term, right? Which is negative 5. Plus n. What's n? N's always number of terms. Yeah. 42nd. I want to find the last one's the 42nd. Remember, the ordinal is always in. Ordinal, 42nd is an ordinal number. It implies an ordering, doesn't it? 42nd, as opposed to just 42. That's not an ordinal number. If they say 42nd, they're implying ordering. That's always your n. Minus 1. The d, what's the d? Yeah, that's the minus 4. And we have to multiply by that, don't we? So there we go. Minus 5 plus 41 times minus 4 minus 5 minus 164 minus 169. It's not there? None of the above. Is that good? Questions on that? All right. Okay. Movie theater, $8 for adults, $5 for children, 40 people, $272. How many adults? All right. Money problems. Do you remember how to do those from your algebra days? Word problem. One equation that has no money in it. A second equation that's all about money. So first equation would be adults plus children. Which one of those numbers up there has no money involved? So $8, that's a money number. $5, that's a money number. $272, that's a money number. 40, no money. See, I know the 40 goes in the top equation. Top equation is no money. It's just total. Adults plus children is 40 people altogether. And the next equation, you bring in the money. It's $8 for every adult, $5 for every child, and the total money, $272. So I got that second equation. That makes sense. See how that equation has money all the way across? So in a money equation, you break it down, no money, money. All right, so how do you solve two equations with two letters? At this point, you'd have your graphing calculator. So if you want to just type in, this is a 1 there, 1, 1, 40, 8, 5, 272, and hit RREF, boom, you have your two answers. You don't have to do any by hand work. You'll have your graphing calculator. And I've heard time is a concern on this test, at least for some people. I'm teaching this class online as well. One of my online students let me know that he felt like he was running out of time, and he's a good student. He's getting an A. So make sure there's not time to delay. There's not time to get to a question and then not be sure. Anything that you're not sure of, just move on. Right, on a time test, just move on. Come back to the ones that are harder for you.
Will we be going over a lesson that day?
Yeah, no, we have the hour and 15. That's it. So the 2-hour class, we have to do half an hour lesson first. Yeah. Yeah. No, the exam is designed for an hour and 15. I think if you really know what you're doing, when you see a question, move right on through. Yeah, there's not time for stopping and trying to figure things out, but there is time if you just know immediately what you're doing. So put that into your calculator, and you guys know how to do that? Is that good? It's a 2 by 3. This is a 2 by 3 matrix, right? Down 2, 3 across. 1, 1, 40, 8, 5, 2, 7, 2, 7, 2. Second quit. Second matrix. Go to math. Go down to RREF. Second matrix. I'm getting 1, 0, 0, 1, 24, 16. Did you get that? And how do you know which answer is which? 24. Which one's the 24? Yeah, it's whatever letter came first and then whatever came second. So this is adults. This is children. 24 adults, 16 children. What do they want? They want adults. 24 adults. Is that okay? So I would just do everything on part 2. All the 2 equations, 2 letters, and 3 equations. Just use your calculator. Do the RREF on that. Rudy? Yeah, whichever letter's on the left, that's going to be on the top in your answer. So I'm saying first you go left to right, top to bottom.
But I bet you could just ask.
So the letter on the left becomes the one on the top. So letter on the left becomes the letter on the top.
To get the other answer?
All right, let's move on. Okay, Ellen wishes to mix candy. How to do mixture problems?
Like the answer?
Yeah, or beakers, boxes.
I
I wish to mix candy. And you put the percentage, or in this case the money value, on the bottom. Like that. And so remember, so that's how you do these mixture ones. You put the money at the bottom, or the percentage if they're mixing acids or something like that, And then the 24, where's that going to go? You put the amounts in the top. It says 24 pounds of the 264, so that'll go right there. So you put the amounts on the top and the money on the bottom, or percentage. So it's a percentage problem. All right, what do we do with those 2 blanks? X and Y. That's my X and my Y. Okay, so 2 letters, we need 2 equations, don't we? So my first equation, where's my first equation come from? Yeah, right across the top. So X plus Y is 24. That just means total pounds of candy out of the first box plus total pounds out of the second box is total pounds in the mix. Everybody seen that idea? This whole beaker is added to, combined to that whole beaker or bucket or whatever, to equal the final mix over here. right? That one on the right is the final mix. Everybody say we're pouring the first two into the final one as a final mix of candy. We're mixing cheap candy with more expensive candy to get candy in the middle. That makes sense, right? Something more expensive, something cheaper. The final mix will be mid-level price. Okay, so amount out of the first bucket plus amount out of the second bucket is total pounds in the final bucket. Second equation comes from multiplying top and bottom. So you multiply the top and the bottom. So I multiply these two. 1.08x. Multiply these two. 3.05y. Multiply these two. 24 times 2.64. That equation represents total money, doesn't it? What are the numbers on the right? Somebody have that 24 times. Thank you. This comes out 63.36. Well, that 63.36 is total dollars. That's the worth of the mixture, right? If we have 24 pounds of candy worth $2.64 per pound, that will be total value of $63.36 of candy. That's the total monetary worth of the candy in the end. Well, that comes from $1.08 candy times X pound per pound times X pounds, $3.05 per pound candy times Y pounds, total pounds, total dollars. All right. How are we going to solve this? Now that we have this, I would use my calculator. I would go 1, 1, 1, 1, 24, 1.08, 3.05, 63.36, do RREF. Let's hit the buttons. What's that?
Could you do like right here so I can see?
Yeah, I could. How about I write it? Yeah. So to do that, so you've got to enter the matrix. So yeah, let me see. So yeah, so you've got to go second. So on your calculator, second matrix, and when you do second matrix, you've got to go across twice. How am I doing on the screen? To the edit menu. And hit enter. So that's the first thing. And then you got to put in the matrix. And then you got to hit second quit, which is right across the top. Got to quit that matrix. And then, so let me do that. Oh, and it's a 2 by 3. You got to tell it it's a 2 by 3 matrix. Then you go second quit, and then you hit second matrix one more time. Go over to the math menu, on the screen there barely, and go down to RREF and hit enter. Oh wait, there's one more step, huh? RREF, I forgot. One last step. Final step. Then you got to hit second matrix one more time. And then just hit enter a couple of times. And you get your answer. I'm getting a decimal 4.99. So there's the instructions. So here's all the steps to do on your TI graphic calculator to get the answers there. And so the answers I'm getting, let me write them up here. I'm getting 1001 like always. 4.9949, and this is 19.005, whatever, like that. So this must be X, this must be Y, right? Whatever letter's on the left is on the top. Everybody seen that pattern? So this is X, this is Y. Which one do they want from me? Yeah, look at their question. They say, how many pounds of the more expensive candy? Which one's the more expensive candy? This one, the $3.05 candy. That's Y. So they actually want Y, don't they? So they want 19. That's approximate answer there. 19. So that it's not there. None of the above. The answer is 19. None of the above. Is that good? Questions on that? You able to do that? If there's a mixture one on the test? All right, I'm going to move on. One of my previous students just transferred to UC Davis a year ago for chemistry. And my own little daughter likes chemistry for some reason. No, I'm just not a big chemistry fan. Anyway, she just made her big decision. She got accepted into Cal Poly, but I told her we can't pay for that. Her older sister is already at Cal Poly. With the $15,000 deal, that's I'm letting you know my family's deal. We're one income family, 5 children. I don't know why they won't give us any money for these kids, but they always say, I guess junior college salary they think is plenty. So anyway, they don't give me any money at all. So I always say, I can pay for Fresno State for like 2 years. That's it. After that, it's on you. 5 kids, no way I'm going to make it, otherwise. So that's the deal. My Emma girl said, that's okay. I'm going to Cal Poly. I just want to be by that beach. And so she's there, and she will pay back $15,000 a year in loans for every year she's there. Just 2 years, though, probably. But my next daughter, she was also invited to Cal Poly in biochemistry, and she had till Monday to decide. And she waited the whole period, and on Monday she said, I'm going to do Fresno State. I'm just going to stay local. I think it was a wise decision for her. Not that the other one made a bad decision, but I think it was a good decision. All right, anyway, we have a friend at church that has his doctorate from Fresno. Well, he did his chemistry at Fresno State and went on and got his doctorate. And I had him talk to her a few weeks ago. I said, come talk to, maybe you guys know Mr. Anderson. He teaches at Clovis Community College. Mr. Anderson. Anyway, Dr. Anderson. And I said, come talk to Mr. Anderson after church one day. I said, hey, this is my daughter Lizzie. She just got her. And is Cal Poly like really a lot better than Fresno State? And he said, everybody at Fresno State, we all went on for graduate degrees. So I know my daughter was like, oh, okay. And he said, you'll get a lot of attention there. Small program, people work with you. So I'm happy I like her. I like that she's staying around. All right, anyway, there's my little family story in chemistry. So keep my daughter around for a few years longer here. So all right, A1 and AN. So recursive formula here. So how are we supposed to do this? They're giving me, these ones are easy if you know what they're saying. It looks like a foreign language. They're giving you the first one, and they're wanting you to plug in to get the other ones. So you're giving you the first one. A1 is 2, and then they want you to crank out the other ones. So the first one is 2, A1 is 2, and then the other ones are by cranking out. So AN is 3, AN minus 1 plus 4. Like that. So, and what is AN minus 1? It's the previous. So it's saying any term is 3 times the previous, add 4. Does that make sense? Any term is 3 times the previous, add 4. 3 times the previous, add 4. So they're giving me the first one. It's like a seed, and I'm going to grow the rest of them. So if I want to know there's A1. So if I want to know A2, what is it? It's 3 times the previous, add 4. So that'd be 6 plus 4, 10. So A2 is 10. So that makes sense. I'm going to do it again, but so far so good. So it's all about understanding, being able to speak this language. Because I think if you speak that language, it's pretty easy. It's just any term is 3 times the previous. See, AN minus 1, that's 1 back. 3 times the previous, add 4. So if they give you the first one's 2, then the next one is 3 times the previous, add 4. So it's 10. Okay. Let's find A sub 3 now. A sub 3 is what? 3 times the previous, add 4. What's the previous? 10. So that comes out 34, huh? And then a sub 4, what is it? 3 times the previous, add 4. What's the previous? 34. So it's 90, 102, add 4, 106. So that's it. It's 2, 10, 34, 106. 2, 10, 34, 106. There it is. So it's all about, is this speaking to you? Not good? All is well? All right. So on we go. All right, 5, 3, 3, 2. Find the inverse matrix by hand or with the graphing utility. I just hit the buttons. You guys know how to do this on your calculator?
Just do flips and negative signs.
You could, but then you got to divide them all by the. Oh, you might have got lucky. It's 1, but it won't always be 1.
Yeah, but this one's simple.
That's true. Okay, so if you know that, that's great. Yeah. So you can do it by hand or do it with your graphing calculator. You can just put that thing into your graphing calculator. 5, 3, 3, 2. Just put it into A, like we showed a minute ago, and then just do A, and then hit that x to the minus 1 button, and hit enter, and you'll have it. Yeah, the by hand method. Jeffrey's totally right. The by hand method is not too bad either. The by hand, if you wanted, is you take the 5, 3, 3, 2, and you switch this, and so that becomes 2 there, 5 there. You put negatives, where I got to make it a little bigger, don't I? You switch the main diagonal, put a 2 there and a 5 there. You make the other 2 negative, like that. And then you divide all 4 of them by the determinant. That'd be the by hand way. You don't have to do it by hand. You can just hit the buttons in the calculator. That's fine with me. This will be on part 2. I promise. I won't move it to part 1 all of a sudden on you. I won't move anything. Everything will be where you see it is. So you can just use your calculator. The determinant is the main diagonal, which is 10, minus the other diagonal, 9. See, it's 5 times 2 minus 3 times 3, which is just 1. So you divide them all by 1, nothing changes. That's why I say it's kind of a lucky one. It's real nice that way. So there it is. 2 minus 3 minus 3, it's C. Again, wasn't the last one C? Is that good? All is well on that. We'll move on. All right. Okay, so they're telling me the 6th term and the 15th term. How do you do these? Arithmetic. It's telling me arithmetic sequence, isn't it? So which formula am I going to use for arithmetic sequence? The A sub n one. It's not S sub n. We're not adding anything here, are we? So there's no plus signs anywhere. So it's the A sub n arithmetic, which is right there on the first page of the test. A1 plus, what is it? Oh, n minus 1 times d. N minus 1 times d. We good? All right. So here we go. It's saying 6th term. Where's that 6 go? That's in. Remember, ordinals are always in. Anything with a TH or an RD, 3rd, 7th, 25th, all those are ordinal numbers. They imply an ordering, right? Like if you ran in a race. I just found out yesterday that our secretary in the math, science, engineering, she runs marathons. That just seems amazing to me. I have trouble running down the street. I'm exhausted. But yeah, she runs marathons. So there's, I'm sure, a place she comes in. 57th or 23rd, or right? That's an ordinal. That implies ordering. So that's in. That's always in. A1, that's the first term. I don't know what that is. In, there's that ordinal again, 6. Again, the in is always the ordinal. The ordinal is always in. And I don't know D. But they do tell me that the 6th is equals 27. Bless you. See how I got that first equation? A sub 6 is that formula, and it is 27. It equals 27. And then the next one, now we'll use this information. 15th, there's in again, ordinal. A sub 15, right? 15 in the in slot is A1, I don't know. In is 15. times d, I don't know, and it is negative 63. Good there? So we got our two equations with two letters. A1 and 6 minus 1 is 5d. And 15 minus 1 is 14d. Like that. Like that. And so we have two equations, two letters. See how A1 and D, that's like my X and my Y, right? So two equations, two letters. What do you do? Yeah, just run a negative. I'm going to put a negative 1 through the top one, let's say. Bottom one, whatever, just one of them. Add them up. A1 minus A1, gonzo. 14D minus 5D, what's that, 9D? Minus 63 minus, what's that, minus 90? Yeah, 90, huh? So 9D is minus 90, bring it up here. 9D is minus 90. Divide by 9. D is minus 10. D is minus 10. Of course, two of them say D is minus 10. Got to get A1 now. How do you get A1? Just plug in somewhere, huh? Where? I don't know. Yeah, you could just grab, how about, it doesn't matter. How about this one here? I'll just grab this one. A1 plus 5. Before I put the negative through it. You can grab it before the negative. It's the same thing. Plug in the negative 10. A1 plus 5 times negative 10 is 27. A1 minus 50 is 27. Add 50 to both. A1 is 77. So there it is. C again. If in doubt, choose C. Good on that? Oh, it went off the screen a little bit. Sorry. I don't know why this projector's so off today. I always want to throw things at that thing. I don't know why. Why does that one move all the time? Maybe they need to bolt it down better. All right, good. Questions? All right, so 25. Coefficient x to the 8th and that expansion thing there. What do? Binomial formula. Remember what that works? It's all about that power, isn't it? 7th power. So what do? You start with that power 0, that power 1, that power 2, that power 3, that power 4. You keep going, but we don't need to do all of them. We just have to find the one that has x to the 8th. So first off you do that, and then you start with whatever it's a binomial theorem, two items. You start with the first item there, which is x squared, and you go 7 power, 6 power, 5 power, 4 power, 3 power. Now wait, which one do I need? This one. There it is. Because that's my x to the 8th. Everybody see how that's going to be x to the 8th? 2 times 4 right there. It's going to be my x to the 8th. That's the only one I really care about. Right? So now grab the second part of the binomial to the 0 power, 1 power, 2 power, 3 power. All right, 7. Okay, use your calculator. You guys know how to do the 7-3 thing, right? 7, choose 3 on your calculator. I think it's 35, isn't it? 35. And then it's x to the 8th, and that other part's minus 27. So if you multiply those together, you get minus 945 x to the 8th. There it is. Okay. That's not bad, right? Questions on that one? Yeah, Rudy.
Why did we stop that again? Something with the x to the 8th.
What's that? Oh, because they're asking. They say find the coefficient of x to the 8th.
Oh, yeah.
That's all they want from us. Whereas the next one, they want the whole thing. Yeah, so this one, they just wanted us to go to x to the 8th and stop. Like that. All right, let's move on. Okay, 4x plus 2 to the 5th power. Binomial again. Here we go. You remember, it's all about the power, huh? You start with the power. 5, 0. Oops, here. Make sure I have room here. So, 5, 0. 5, 1. 5, 2. 5, 3. 5, 4. 5, 5. That on the screen? Good. Times. Then you take the first piece of the binomial there, the 4x, to the 5, 4, 3, 2, 1, none. And then take the other piece of the binomial, the positive 2, to the 0. Remember, he goes backwards, right? The other piece, the binomial that goes back, starts at 0. 0, 1, 2, 3, 4, 5. There it is. So let's just work these out. So 5, 0. Remember, anything with a 0 is just 1. That's 1. Now, 4 to the 5th power, use your calculator, 1024, right? X to the 5th, and 2 to the 0 is 1. So that's just 1024 x to the 5th. Next one. 5 choose 1, that's just 5. Anything with a choose 1 is just itself. 5. 4 to the 4th, 256. X to the 4th. Times 2. 2 to the 1 is 2. That's 10. So that's 2560. X to the 4th. Hey, it's looking like D right now, isn't it? Let's see if it keeps going. 5 choose 2. That's 10. Times 4 to the 3rd. 64. X to the 3rd. Times 4. 6, 4, 2. That's 2560 again, isn't it? 260. X to the 3rd. Oh, yeah. That's the next one. And then 5 choose 3. That's going to be, remember these repeat? 1, 5, 10. 10, 5, 1. Remember how these repeat? So you want to know some of these things to make sure you're quick. 1, 5, 10, 10, 5, 1. And this will be 4 squared, which is 16x squared times 8. It's at 8, 16, 32, 64, 128, 1280. X squared. Yeah, it's beautiful. And the next one is just 4x, 2 to the 4th, 16. 3, I don't know what that is. I have to look up. Is it 320? Is that right? 20. Yeah, it is. Okay. And the last one, anything to the 0 power? 4x to the 0 power? Just 1, huh? Am I going too quick? Am I racing ahead of you there? Right? Anything 4x to the 0 power, anything to the 0 power is just 1. And 2 to the 5th is 32. It's 32. Perfect. It is D. The binomial theorem. You're going to have, I put probably one example on your 3x5 card if you want to. Because it's just, then you'll have the pattern. Put one example on there. Projector's getting tired. You guys getting tired? 10 minutes. All right. Let me show you what I mean. Yeah, so I would do this one. See, we're using our graphing utility. 10, 3, negative 4, 15. 9, negative 7, 7, negative 3. 3, 4, this is negative 1 here, negative 1. 12. Do that, do R, R, E, F, and hit the buttons. Yeah. Sure. So I'll move on. So what's the answer on that one? You guys getting quick at that? The more you practice it, just like, remember when you tied your shoe when you were a little kid, it took you forever? Just like that. If you do these with your calculator and all these problems, more and more and more, you'll get faster and faster. You got to be kind of quick on this test. Boom, I just did it. I just did the whole thing on my calculator. X came out 1.03448. Yeah, so it's C, huh? It's always C. Yeah?
On the YouTube, you kind of did it differently.
Oh, I probably should with the inverse function.
Yeah.
Yeah, that was okay too.
Okay.
Yeah. Yeah, either way, this is probably easier, RREF. But the inverse function thing works too. Yeah. I showed you that in the homework. It's probably where I used up all of my time. But if you go into higher math, you need to understand that inverse function stuff. So, but right now I'm just going to get you ready for the test. But if you want to talk more about that inverse function stuff, feel free to come by office hours. But I did want to show you that once for higher math. Okay, what was the other one? 17 or just somebody?
Yeah,
17? Okay, so see how they're adding them up? And it even says infinite geometric series. So which formula do you think we're going to use if it's infinite geometric?
A1.
S of infinity. A1, yeah, A1 over 1 minus R. Yeah. Yeah, A1 over 1 minus R. Let me show you. So you go back, back to the beginning here. Wait, where is it? There. Right, so here's the S sub infinity formula. How do we know we want that? Well, they said infinite geometric. This is geometric. These three are geometric. These two are arithmetic. Right? You start with the easy stuff. The first two are arithmetic. The last three are geometric. They're harder ones. And this is the infinity one. S sub infinity.
There is no infinity for arithmetic.
Right. Yeah. Okay, so there's the infinity formula, A1 over 1 minus R. Now, why do I say, maybe it diverges? How do you know if it diverges or not?
Does it get smaller?
Isn't it between -1?
Yeah, remember, it's okay to use the formula if, I'm off the screen, huh? It's okay to use this formula only when R is between -1 and +1. R has to be between -1 and +1. Otherwise, if R is greater than or equal to 1 or R is less than or equal to -1, it diverges. That's when you say diverges. If the R is greater than or equal to 1 or less than or equal to -1, if it's not between -1 and +1, you can't use that formula. I mean, you could plug stuff in, but you're getting garbage. The answers it's telling you are not the real answers. It actually diverges. Anyway, so what's our R? We better figure out R. Sounds like R is important. How do we figure out R? D stands for difference. That's the other formula. R stands for ratio. Remember, you take the second term over the first term? Or you can just look and say, what's happening from term to term here? If you can tell, great. If you're not sure, take second term divided by first term. 8 over 32, second over first. You can take any term divided by the previous term. It's a common ratio. It just keeps doing the same thing. Then reduce that fraction 1/4. Right, I just divided by 8. Top bottom. So the R is 1/4. Is that between -1 and +1? Absolutely, right? If you have -1 here, +1 there, here's 0. 1/4 is about right there. It's between -1 and +1, isn't it? So it's in the zone, which means green light. You can use the formula. It'll tell you the truth. So we can use it. So here we go. S sub infinity is A1 over 1 minus R. S sub infinity is A1. What's A1? A1 is 32 over 1 minus, what's R? 1/4. There it is. 32 over 1 minus 1/4. Let's clean that up. 32. What is 1 minus 1/4? Yeah, right? If you have 1 whole pi and you subtract 1/4 of a pi, you have 3/4. Good. And then grab that and flip it up. I'm getting off the screen. 32 times 4/3. That's 32 over 1. What's 64? 128 thirds. 128 thirds. There it is. Converges just means it comes to an answer. It doesn't go off to infinity. That's what diverges means. It goes to infinity or just never goes anywhere. It doesn't land in an answer. But ours converges to an answer, 128 thirds. Good. Other questions? Yeah.
It's just about this question because I know I got this one wrong, and when I did it, because I thought geometric, I thought it went when you did the ratio, I thought it was both ways. You can do division and multiplication, but then when I put in 4, I got some really weird answer. So you can only use multiplication then for these, right? So it can only be like times 1/4, not divided by 4.
Oh, I see what you're saying. Yeah, good question. Yeah. You're totally right. Yeah, you're saying what times, not divide. You're right.
Yeah, so then I put the R was 4, not 1/4.
Right, yeah.
Because I thought it goes the same for multiplication and division.
Right, but instead, you should think division is upside down multiplication. So if you want to, if you go, okay, 32, it's dividing by 4, then you should think, oh, that means multiplying by 1/4, and I've got to use multiply. Yeah, so this R is always what's multiplied.
So it's just like this. If it is divided, then turn into a fraction.
Yeah, that's right. That's right. Rudy, question. 16. Okay. Okay. Round the answer. Sum and round the answer. So how do we do that thing? When you see these powers up here like this, that's geometric. You know right away that's geometric. I'm going to use the S sub n geometric. Let me go back and find it. There it is. I'm going to use this one right here. It's the S sub n geometric. We see it, A1, right? Because the K up in the power means that's a geometric sequence. A1, 1 minus R to the n over 1 minus R. A1, 1 minus R to the n over 1 minus R. And what we should do is crank out a couple of terms. So if I take this formula and I plug in K equals 1, I get 1/4 times minus 3 to the 1 minus 1. I plugged in K as 1. Work that out. That's 1/4 times minus 3 to the 0. That's just 1/4. If I plug in K as 2, I get 1/4 times minus 3 to the 2 minus 1. 1/4 times minus 3 to the 1 minus 3/4. How are we doing? So I just took that formula, 1/4 times minus 3 to the K minus 1. That's the power. And I plugged in 0. I plugged in 1, right? Because it says you start at 1. And I plugged in 2. I got the first term, the second term. This is A sub 1. That's the first term. This is the second term, A sub 2. How do I get the R, the ratio?
Second term.
Yeah, second term divided by first term. So this over that. So minus 3/4 over 1/4. So minus 3/4 over 1/4. Grab this thing, flip it up. On the screen still? Yeah. Cancels out. So R is minus 3. So we have R. We have R. And so now we can use our formula. So S sub n is A1. A1's 1/4. Times 1 minus R. R is negative 3 to the n. Now what's n? 13. Number of terms. 13, huh? Over 1 minus R, which again is negative 3. So this is 1/4 times 1 minus. Now negative 3 to the 13th, I don't know what that is. Something huge. Wow. So I got negative 1594323 over 1 plus 3 in the bottom. which is 1/4, so that's 1/16. Times 1 plus 159, 4323. Am I going too quick? See what I did there? Oh, we're running out of time, huh? This 1 and 3 made 4. 4 times 4 made 16. We seeing that? See what I did? I multiplied those two on the bottom. That making sense? And then, so the rest, just use your calculator. And whatever you get, 159, 4324, 16. I'm getting 99645.25. A, yeah. Is that good? I think your calculators will do it too, right? There's some kind of way to find the summation thing on there. Feel free to go on YouTube and try to figure that out. This will be on the graphing calculator part. Go on YouTube and learn how to, there's a way you can just type the thing in and boom, it'll do it. Click A for Apple, free click, and we are done. Question?
What day is the final?
Yeah, our final is 2 weeks from today, the 17th, May 17th, Thursday, 2 weeks from today, normal class time.
This area.